today we're going to get more involved in the discussion of all these different integrated weed management tactics we can use. We'll be discussing integrated weed management of palmer amaranth, common ragweed, and marestail, just as some example species. Our first presenter is Dr. Vijay Singh with Virginia Cooperative Extension. Vijay.
Hi, everybody. I'm Vijay Singh, Assistant Professor and Extension Weed Specialist at Eastern Shore AREC. So today we would be going through the integrated weed management programs and what we can integrate along with the herbicides for managing our troublesome weeds. We would talk about tillage practices, crop rotations, using different cover crops, and there are some few new technologies which we are bringing in Virginia, and we have some examples from Eastern Shore region as well. So let's go through the slides. So I hope you are able to see these slides properly. So the slides, we have a combined pool from the researchers from University of Delaware, Maryland, and Virginia Tech. So these are all the combined efforts and research we conducted so that we can gather more information for you. So you might be thinking what weeds can do apart from damaging the crops and lowering down their yields. And by looking at this picture, you might be thinking that weeds can cause accidents. And when we talk about weeds, so looking at this picture, you might be thinking only about one weed. But yeah, we are serious. Weeds can cause accidents, and it's not just related to this picture, but it's more related to the picture coming next, like this. Now, this is from January 1, 2020, this year, and you can see how the tumbleweed engulfed the whole car and trucks. And so weeds can be of any type, and they can cause serious accidents. So that's why we always talk about integrated weed management. Sometimes it's not always easy to control those weeds just with herbicides. So now how we assess those weeds which are more problematic for our fields. And it's not just about controlling those weeds in current session, in ongoing season, but also we need to assess how much seed they can produce. Can we use some other tools to control that? Maybe harvest weed seed control would be a better idea to reduce their infestation in the coming years. So these are the approximate number of seeds a weed can produce. Like for the barnyard grass is about 7,000 seeds per plant it can produce. Now, if we talk about the palmer amaranth, that can go up to 600,000 seeds per plant. So that's really, you can expect, like if you are not controlling one particular plant of palmer amaranth in a field, it can give rise to hundreds of thousands of plants next year. So what is IWM, or integrated weed management, and how it is different from the herbicides applications or controlling weeds with the herbicides? So IWM is the practice of using multiple weed management tactics. As I indicated earlier, that we can use crop rotations, tillage, harvest weed seed control strategies, stale seed bed techniques, and it includes actually herbicide. Herbicide is one of the component. It doesn't exclude herbicides from that. So these are all the combinations, and there are some biological, basically, when we talk about the integrated weed management, our focus is more on prevention rather than killing the weeds after they have already emerged. So we try to utilize all the strategies so that we can prevent them. And also the prevention, when we say prevention, our major focus is to prevent the weeds from producing seeds. So that's our goal, so that they won't produce more weed populations next year. So these are some of the preventive practices like plant certified seeds, which should be weed free, and do not let weeds to set seeds. So that's the main important point here. And for that purpose, we use crop rotation. We conduct routine scouting or surveys, clean harvest and tillage equipment so that our seed would not spread to the neighboring fields. Then do not introduce infested hay, straw, manure, or soil into clean fields, because I understand, we all know that because of the soil seed bank. So if you are bringing some seed from the neighboring field, you are bringing some weed seeds as well to that field. So timely scouting. What is timely scouting? So like what weeds are present in the fields. That's very important. The first slide, which I show you about the weeds and how much seeds they can produce. So that's why this is very important to know what weeds are surviving in your field, whether those are herbicide resistant or not, which species, how much is the infestation in the field. So those information would help us to devise a better management program. So this is an example of the crop rotation. So we would go with one by one with all the strategies and would highlight how we can utilize those integrated weed management strategies in your field and how to manage those troublesome weeds of your crop. So here you can see that there are two fields. One is just in front of you and one is in the back. So the back, that field was actually rotated with soybean. So soybean was planted in 2008, and then that was rotated with soybean again in 2009. So there was no change in the herbicide programs or any other management strategy. Now, field in front of you, you can see that in 2008, there was tobacco in that field, and then it was rotated by soybean in 2009. Now, why you see this field more cleaner compared to the one in the back? It's just because we rotated the different crop, and it is not just about rotation with the different crop, but actually we are rotating on using weed management strategies which were different from the previous year. So that's the overall purpose. Now in tobacco, because of the high value crop, so there were many like mechanical and manual weed management operations, which we don't see normally in soybean. And that's one of the reason you can see how much is the difference in weed infestation in these two fields. This is another example to assess how crop rotation can help us to reduce the weed density. So there are two bars here, one is blue and one is red. So both of these are actually indicating how much was the weed infestation in the field, like plants per acre. So you can see that there's a difference like by 1/3 or near about 300% decrease when we rotated sorghum followed by soybean. And here in the first bar, it just shows that we had soybean and then again soybean next year. So you can see 100% decrease in weed infestation of palmer amaranth. Now, this is not something that you would think that only soybean, if sorghum followed by soybean can only reduce this much. If you have corn in place of sorghum, still I think it would be a similar effect. But basic purpose here to show you that crop rotation is really economical and viable weed management strategy, which you can use apart from following the herbicide programs pre and post. Now, the second integrated weed management strategy we recommend is to go for the cover crop. And like in this region, mid-Atlantic region, actually farmers are very interested in using cover crops, and I have seen people are normally following these. So now today we would go through this cover crop strategies, what cover crop we can choose and why we would like to choose it actually, how much benefit they can provide us. So now cover crop we plan near about in September or October. So this is the main window. It's possible that we there is a difference in a month window. Some they plant in September, some plant in October. But basically, I would also indicate how that can impact the total biomass in your field and what time you should choose to plant the cover crop. So, for example, we planted in the mid of September, and that's how it looks at that time. And if you go through that, so we actually it's a serial example. We can terminate it by first week of May or end of April. So that time period is very good for actually the cedar rye. And basically, it's a green biomass, means it's a live crop. So it would suppress all the weeds during that season. Especially, we are talking about the winter annuals here. So cover crops provides you an opportunity to suppress the winter annuals. We would talk about the summer annuals as well later on, but here, if we are focusing when the winter annual weeds establish. So normally in October and November area, like the timing when winter annual weed establish, then we see that they go under dormant stage and your cover crop as well. But if we talk about the March and April time, then again, your winter weed, you would see that. And they also start producing seeds February onwards. So this is the window. So if you have a cover crop and with a good biomass, then they would help you to reduce the winter annuals and their seed production. And if the seed production would be lower, then definitely next year you would not see much of that infestation from the winter annuals. This is one of the example now, how cover crops can help you in reducing those weeds. Now, on the left side, you can see there was no hairy vetch. So hairy vetch, we utilize a cover crop here. And on the right side, we have a hairy vetch cover crop. So on the left side, you can see a lot of horseweeds. On the right side, you may see few stands are still there. But if you talk about the seed production, those are actually expressed quite well by hairy vetch, and you may not see that much of a seed production here. And also, you can easily evaluate that next year there will be very few plants of horseweed here compared to the half of the screen you are seeing on the left side. Now, this is another example of the cover crop. Like I gave you example of a hairy vetch. Now, what about the other cover crops? Like for example, Brassica. Brassica we can use, and these are highly competitive cover crops. So this is one of the study conducted where it was a mix stand, like mixed with different cover crops. But what we are seeing here, these were planted in August, and the pictures were taken like in November. This left picture taken in November, and the right picture taken in February. So by February, you can see that they already stands were already disintegrated and towards decomposition. But in November, you can see the high biomass stand, green biomass stand of Brassica. But you don't see much of the stand of the other cover crops. And just because Brassicas are highly competitive, so they smoothed the other crops as well. So if you have some other weeds and even the previous stands of the previous cover crops which you used previously, and they had their seeds in soil seed banks. So Brassica is one of the good option actually, because it provides a competitive effect and it can help you in uh, managing all other crop plants. However, in spring and later spring, you may not see much biomass from this crop. So the strategies where we would like to maintain the biomass on the field and especially to manage the summer annual weeds, there Brassica may not be a good option. So these are some of the example where these cover crops are effective when we talk about the winter annuals. What winter annuals they can control easily? Common chickweed, dandelion, flabeans, Carolina geranium, handbait. So these are the major weeds where cover crops can effectively control. However, this common lamb squatters and common ragweed. So again, I would like to repeat the point I highlighted. If you have a higher biomass in your field and if you can maintain it for the later season, then you may actually delay the emergence of common lamb squatter, common ragweed, and can suppress their initial growth if you can retain the biomass in the field. And that happens normally if you are using cedar rye as one of the cover crop. Now, what cover crop can do? It can provide a similar or a better weed control than fall applied residual herbicide. So if you are using any fall residual herbicide so that to reduce your weed infestation in coming spring, so cover crop would be one of the alternate options, and sometimes it even provides better results. Radish alone effective when planted early. So that's important point I highlighted in the picture in the previous slides, that radish are effective if they are producing very high biomass, but that's only possible if they are planted early, because if you're planting them late, then they may not be able to produce that much biomass. So now we talk about the summer annuals. When we talk about the summer annuals, but we are actually, and normally farmers are planting cover crops in fall and or the later fall. So how they would tackle or control summer annuals, which are germinating mostly in April and going through in that season. So that can happen if we maintain a layer of the biomass of those cover crops in our field. So this is the window, like I indicated first, this green window, it indicates that we planted our cover crops in September, October, and it goes up to end of April or first week of May. If we are terminating, suppose if we are terminating our cover crop 1st of May, so whatever the brown part or the brown triangle area you are seeing here is the residue, means the dead residue. The green one is the green biomass, live biomass, and the brown one is the dead residue of that cover crop. So if you are maintaining that high biomass on your in field, then it would suppress your weeds and also would not allow it to emerge. So that's one of the good strategy to control the summer annual, because this is the time window actually for your summer annual to establish in your field. Now, biomass is the king, as we indicated earlier. That's the main trait of the cover crop, which we need to keep in mind, and main purpose to have a cover crop in your field, especially if you're targeting the weeds. Here, the biomass, some studies indicated that near about 7,000 pounds per acre would suppress 75% of the weeds. But that's not just that we need to have that much biomass to control weeds. Even studies have indicated if we have near about 4,000 pounds per acre, still they can provide a good control of weeds. So, and because that depends on many other factors. It also depends on how much weed infestation you have in your field. So anywhere between 4,000 to 7,000 pounds per acre would help in suppressing the weeds, starting from 50% to 75%. There are some other important consideration like carbon nitrogen ratio, fiber content. So these um factors are important when you decide what cover crops you would like to use in your field. Like legumes can fix nitrogen. So cereal rice are good actually for maintaining the biomass. Um, and Brassica is actually having good uh, control on some of the pests, and they can produce a very high biomass initially for the control of annual winter weeds. This is to highlight the point which I just indicated, that the green portion is the green biomass, the brown portion here indicates the dead residue of that. The blue one actually highlights the difference between the two major cover crops we are highlighting here. The first one is the cedar rye and the second one is the hairy vetch. Now the blue one portion indicates the hairy vetch. So means if you are um, terminating this hairy wedge, that disintegrates and decomposes very fast. Whereas when we terminate the cedar rye, it can stay on a field and act as a mulch to suppress the weeds for the longer period. And it goes up to like June, July, if we have a very good cover or the biomass on our field. So this is the difference now, in terms of a picture, and you can see with your eyes like hairy vetch on the left side. You can see when we took picture 6 weeks after termination, almost decomposed already in that field. Whereas the cedar rye on the right side, it's still on your field, acting as a mulch to reduce the weed emergence. And in terms of the weed emergence as well, you can look at the differences between these two pictures. On the left side, you don't see, in the left side, you see a lot of weeds already emerged because hairy vetch already disintegrated and decomposed. Whereas on the right side, we still have that good mulch. So um, these cover crops are effective on few weeds and ineffective on some of the other perennials. So effective on the common lamb squatters, horseweed, marestail, and pigweed. So these are major weeds actually we would be talking about. So these cover crops are quite effective on this. And then moderately effective on the crabgrass, broadleaf signal grass, velvet leaf, or morning glories. Ineffective on perennials like Johnson grass, horse nettle, hemlock mane, nutsedge. So if we have a lot of problem of a nutsedge in your field, then cover crop may not provide a very good control. Same thing for the other weeds. But then again, integrated weed management is not about just exploring one option. We combine that with the several options so that we can have a very good control. Then what are the main points and what we need to keep in mind when we plant the cover crops? Like planting winter cover crops early can increase the weed suppression potential. And we have already discussed about is even the cedar rye that has the widest window, because it would not only provide a suppression as a green biomass, but would also provide an option for a residue cover later on after we have terminated it. Then plant hairy vetch and forage radish. So these are the timings if we are planting these cover crops so that we can have a very good biomass production. This is one of the example of the timing of planting of this cover crop, how that would affect your biomass production. So for example, if you are planting August 25 and if you are planting in October 15, so that's a difference in the biomass production. So these pictures were taken in April 1. So you can see that if you are planting on October 15, that will not provide you with a good control of your weeds. Means neither winter annuals nor even summer annuals. Whatever the weeds they would come in between these rows. But yes, if you are planting in August 25, September 5, I think this is a good window, means August and September, which would provide you a better coverage biomass for reducing the weed growth or even the emergence. This is a second example. Sometimes some growers, they ask a question, what should we do? Whether we should consider planting little early or we should consider terminating them little late. So these studies were conducted in like 2008-9, and this is quite interesting study, and it provides answer to those questions. So let's take a one, just to give you an example, we'll take one example, either September 25 or 15th of October planting. So if we are using one particular date, and suppose we are terminating in May 1. So this date, the blue dot indicates we terminated in May 1. So the difference here, actually, it is producing near about 2,000 pounds per acre. If you planted in 15th October and terminating on May 1, then it provides near about 2,000 pounds per acre. But for the same cover crop planted on 15th October, and then we are terminating it May 30, means after a month, then the biomass production would be near about 8,000 pounds per acre. So there is a difference of 6,000 pounds per acre. Means if you are delaying the termination, that would help you in building more biomass in your field. Let's compare the different planting dates. One planting date, let's pick this one, the 15th of September, and then 15th of October. So there is also a 1 month difference, since we just discussed about 1 month difference in termination. So we would discussing about 1 month difference in planting dates. So this would help you in gaining 2,000 pounds per acre if you plant 1 month earlier. But if you are delaying the termination by 1 month, you are gaining actually 6,000 pounds per acre. So means there is an additional benefit of about 4,000 pounds per acre if you are terminating it late. So terminating late would be a better strategy if you are comparing with the early planting date strategy. But still, we always suggest to focus on both of these and plant as early as you can and try to terminate as later as you can in the spring. And especially if you are a soybean farmer and if you would like to plant a soybean, you have that window actually, so that you can delay termination a little bit. Now, apart from these main strategies, and you might be laughing that hand pulling weeds, is that a strategy? But yes, that's a strategy, and even it's not, we would not even say that this is scientifically a viable strategy, but economically too. Because as I indicated, that one plant of this Palmer Amaranth can produce like thousands of seeds, right? So if you are seeing any one plant standing in a field, or even a few plants standing in a field, then it's economical to hand pull it instead of using herbicides, or instead of not doing anything and just waiting, okay, we will control it next year. Next year, the problem would be more severe. So it's really viable and economical if you would hand pull some of those surviving plants in your field, especially if those are herbicide resistant weeds and you have tested it. And suppose if you have sent us a sample and we have provided you a report already, then I would suggest look at your field, and if there are only few survivors, please don't hesitate in pulling those weeds. So now I just talk about few plants in the field. So if you see such a field where you have like hundreds of those plants and thousands of those plants in your field, definitely we would not suggest you the hand pulling methodology here. So don't go for hand pulling here because that would not be economical. Uh, we have some other strategies. Now, there are options of harvest weed seed control. If you have a field like this and your weeds are producing seeds before you harvest your crop, and you have a very severe and high infestation, and also coupled with the herbicide resistant weeds, means you don't have many options to control those weeds now. So I'm looking for the alternate management practices. So why we talk about this, because Italian ryegrass, like 110 to 250 uh, pounds per acre seeds, they can produce, and again Palmer Amaranth, uh, this many pounds, common ragweed 200 pounds per acre. So this is a very high amount of seed, which actually when you harvest your crop, and either they would mix with the crop, and then through the back of your combine, they again come back to your field and would replenish your soil seed bank. Um, so when we talk about the harvest consideration, let's move one by one. So if there are operations like harvest operations, so try to harvest in the weed-free areas first and the weedy areas in the last, so that you would not contaminate your weed-free areas first. Then between the fields, clean combine before leaving, especially if you have noticed that few fields are heavily infested with the major weeds. Now harvest clean fields first, weedy field last. I just indicated you. Take advantage of the raining days to clean the equipment. So these are no normal thing, and I think most of the farmers are doing it. Um, there are a few important points, and I would like to highlight here. The field on the top, if you are looking at, so this is one of the field where I would like to show how harvest weed seed control strategies are very important. So these pictures were like captured in April, and like those were after harvest, means after harvest, normally the farmer was using glyphosate to control the common ragweed. And year after, what was happening? So you are seeing all of these weeds are actually in lines, just because whatever combine was throwing the residues in the back of it, were having loaded with the weed seeds, and now they are all growing. And farmers, since he's using uh, glyphosate or the herbicide to control these, so they have evolved resistant to that herbicide, and that's why it means there's no way that he can control apart from using some alternate strategy apart from the herbicide. So now um, this is one of the actually harvest weed seed control strategy, like apart from what I have just indicated. There are some mechanical tools also which kills or removes weed seeds with the harvest operations. Um, First, these were like coming as a impact meal, which we could drag behind the combined harvesters, but now they are coming more in an integrated way. This is a Redecop unit which we can install in the back of the combined harvester, which kills the weeds through the high impact. Um, this is one of the example, actually, if you are in Virginia, um, Michael Fashioner and the group, actually they installed it on the combined harvester at Shockley's farm in which East Shore. You can look at it, and I think we would be installing, and you would see these equipments more on more combined harvester soon, maybe in other states, neighboring states as well, in Delaware and Maryland. So this is a circulatory motion of this Redecop, which actually kills that weed seed through the very high impact, and basically targets the chaff material. So whatever chaff in your crop, like if you have a lot of weed infestation in a field, and when you are harvesting, so your weed seed actually get mixed with the chaff component. So your combined harvester is actually throwing the straw, but if it's mixing with the chaff also, whatever it's just throwing it, then you would be actually spreading a lot of weed seeds. But if you actually separate out your chaff from your straw and can use Redecop for processing your chaff so that it can kill the weed seed. And some studies are actually, these studies were conducted in Australia earlier, and we have seen a lot of success rates in that country. Now we are actually trying to study these here in US as well. So this is not a kind of a very common strategy, but we are actually studying it, and we are quite hopeful that it would work, and many farmers are even excited. And which weed we can target with these kind of strategies, and especially this Redecop or the Harrington seed destructor units. So we are targeting weeds which can actually retain the seed, most of the seed at the time of harvest. So that's a main goal. Like for example, Palmer Amaranth. Palmer Amaranth can retain 95 to 100% of the seeds on the plant at the time of harvest. Now again, the common water hemp, similar. Redwood, pigweed, little lower, but giant ragweed again 80% in about. These units, Redecop, integrated Harrington seed destructors, may not be helpful actually for barnyard grass or the green foxtail, which actually shed or shatter their seeds in the field even before harvest operations. So if they have already shattered the seeds in the field, then we may not be able to collect that weed seed along with the chaff material. And if we won't be able to do it, then these machines may not be effective in controlling it. So we are conducting these studies currently in soybeans, but we would be evaluating actually in corn crop and the other big crops like with the thick stand. Not sure how that would go, but in soybean it's working very fine. There are examples like how much reduction they can cause in the population, like for example, rigid ryegrass emergence after first harvest. So like near about 56% or 57%, that's the same rate we see narrow windrow burning, but that's from the chaff cart actually. We have seen some results on the common ragweed, which is like 80-90% of the control. If we are using this Harrington seed destructors, and Redecop is a similar actually unit. Now, this is one of the, again, integrated strategy, tillage component, how that can help us to reduce the weed infestation. So to go with the tillage, and why we would like to recommend tillage sometimes to fight with the weed infestations. So here on the right side of this, these are indicating left side in the blue, actually the weed, and the right side in the gray, it indicates the emergence depth. Means the barnyard broadleaf signal grass actually can emerge from 0 to 0.4 inches depth. Again, coffee senna about 1 inch up to 1 inch, crowfoot grass about 0.4. So these are the different depths from where the weeds can emerge. Like for example, sickle pod. Sickle pod can emerge from up to 1.8 or 2 inches of depth. So if your seed is on the surface, definitely it would emerge or germinate faster. But if you can bury these seeds underneath your soil, then basically you can keep them for long. If you are keeping them for a longer period underneath, then you can reduce their viability or their ability to germinate or emerge from the soil. So the figure on the right side actually indicates the lamb quarters seed distribution with tillage. This study was conducted with the moldboard plow, chisel plow, and no-till. So if you are using moldboard plow, actually it distributes your weed seeds uniformly, somewhat uniformly, I mean, at different depths. If you talk about the chisel plow and no-till, most of the seeds, like 61 or 74%, were on the surface, whereas there are only 9% or 17% of them were underneath the soil, like at the deeper depths. Whereas if you compare it with the moldboard plow, they're about 37% on the surface, and uh, near about 65% of that, like underneath, um, at 2 to 4 inches or 4 to 6 inches. Now, if the seeds are in that deeper depth and you would not disturb it later on, then it's possible to reduce their viability. If you are using moldboard plow again and again, you can, like, it's possible that you would bring them back again to the soil surface. So it all depends on what weed species you have in your field. And that brings back to the same slide where we talk about the scouting. Why scouting is important, why it is important to know the weed species present in your field, and the percentage of infestation, so that we can come up with the ideas and devise a good management program for your field, how to control those troublesome weeds. So this is an example of the same weed species like we were talking about, where the tillage operations would be more effective. So loss of seed from the soil seed bank. If we talk about the common lamb squatter, so how much is the, like how many years it can survive? So common lamb squatter, if we talk about the 50% seed loss, it takes near about 12 years to reduce the 50% of that seed. If we talk about the pigweeds, then it takes near about 3 years. Common ragweeds, near about 2 years. So means if we are using moldboard plow, then that would be quite effective for pigweeds, common ragweed, large crabgrass, giant foxtail, because in that way we can reduce their viability if we are burying them in the soil. But when we talk about the common lamb squatters, may not be a good option because it takes near about 12 years. And also depends on how much is the depth. Like, for example, if we talk about the horseweed, for horseweed, most of that germinates from the soil, and there is no need even like for the moldboard plow, because even if you are using chisel plow, or if you can maintain a good residue or a little bit of soil on the top, still you can actually prevent it from emerging. So in that case, we need not to go for the moldboard plow. But yeah, for other weeds, moldboard plow would be a good strategy if you are practicing it once in every 4 or 5 years. So these are some of the competitive practices which provides advantage to the crops, like crop rotation, we already discussed about, narrow row spacing, fertility. So higher seed rating, planting date, we talk about. So let's talk about this narrow and row spacing. I would just give you a few example here. So for example, the soybean planting date in row crops. So this is a 15-inch row crop planted soybean, and you can see there's no weed in between, because these are not even allowing space for weed to emerge. So then your crop becomes quite competitive in fighting with those weeds. If you have a more spacing, like for example, the example given here is a 30-inch rows, and you can see actually you are allowing more space for the weeds to grow. Um, so this is not a very straightforward thing that if you have a narrow spacing of 15, then only you can control weeds, and 30-inch rows would not be even effective for managing the weeds. There are several ways of doing it, and it depends on several factors: the herbicides you are using, variety you are using, what's your yield target. So there are several things, but yeah, this is for sure. If you have a narrow spacing, that would add uh, to the competition level of your crop. Your crop would be highly competitive in fighting with weeds. Now we are focusing on three major weeds here. For example, Palmer amaranth, common ragweed, and horseweed. So these are the three troublesome weeds. So I would just highlight the few main points on these weeds, how you can identify them, and what particular strategies we can use to control these. So Palmer amaranth. So Palmer amaranth, you can see this plant actually. You may get confused with water hemp sometimes, or the similar looking plants. But one thing you would notice, this petiole of this leaf is actually either it would be longer than the leaf, or it would be actually of the same size. You may not see the same case with the water hemp or other plants. Second thing here at the inflorescence stage, um, male or female flower. So they can look at this similar from the distance, but actually female flower would have a lot of spines on that. So if you can touch it and grab in your hand, if you're feeling it spiny, then it's actually a female plant. And usually you see a lot of watermarks, like this white watermarks on the palmer weed, but that's not the case actually. 100% it's not. So the picture you are seeing on the top, it's a palmer leaf, but you don't see that white watermark. So just don't get carried away by this watermark only, that look for the palmer amaranth. But yeah, there are different versions of that. But mostly this the lower um, bottom area of this leaf are more wider compared to this upper area. So that's one of the typical way of looking at the palmer leaf, amaranth leaf, and to identify it. Now the common ragweed, even at the seedling stage, and when you have it just emerged, you can see these three lobes, or separating into three lobes, and that carries on even forward when the plants is bigger. In bigger plants, you can see this lobing even more clearly, and more branched lobing of those leaves. But it's not hard to identify it at the even seedling stage when the plant is very small. However, this horseweed, this is quite tricky, because at the seedling stage, or when it's just emerging, the shape of the leaves are totally different if you are comparing it with the plant at a later stage, or even at the seed producing stage. And pictures are just in front of you. So you can see how much is the dissimilarity between these stages. But yes, you would see some hairs on the top of these leaves, and here also in the later stages. But this is a rosette stage, and that's actually for the horseweed, we target the rosette stage of this weed, so that it can be effectively controlled. It's very hard to control it at the later stages. So for example, these are the key biological characteristics of horseweed. So life cycle, both winter and summer annual, emergence period, fall and spring. So either it would emerge in fall, and you may not see during the winters, but again, you would start seeing that in the spring or early summer. And the flowering is normally in August. So if you have used a good herbicide program to take care of your horseweed in your standing crop, so that means you would not only actually controlling that weed in that standing crop, means in season control of that weed, but also preventing the seed production of that weed. If you prevent the seed production, then next year you would not see that high infestation. And this is the important point here. I just highlighted in previously that the seed emergence depth is 0.25 inches. So if you can bury your seed with the normal even tillage operations, like up to 0.5 inches, half an inches, still you would be able to actually prevent its emergence. So it's not very difficult to control horseweed with the tillage operations. And that's why we talk about the integrated approaches, because sometimes we may not have a very effective herbicide control for controlling horseweed, especially when it is herbicide resistant. Response to tillage, very susceptible. Just I indicated that it's very susceptible to tillage, and tillage is one of the actually very viable and good option to control the horseweed. Stale seed bed techniques. So basically allowing your weeds to emerge before planting of a crop, and use tillage operations or any herbicide, like for example, if you are using glyphosate, if it's not a glyphosate resistant horseweed, then that would be even effective to control this. Then crop rotation, planting date, we already talk about, but it is easier to kill when it's in rosette stage, fall or early planted. Growth rate slow in fall or spring, but you would see that later in later spring or early summer, you would see a good fast growth of this weed. Special consideration, very small wind dispersed seeds, so that can disperse to the neighboring fields and go infest your other fields as well. So it's important to prevent your horseweed not to produce seeds. And this is one of the example of the cover crop, how we can use cover crop to manage this horseweed. On the left side, if you see, there was no cover crop, and you can see how much is the infestation of horseweed. On the right side, even though, so we had a cover crop, and actually we used a burn down application with like glyphosate. But this weed on the right side was actually herbicide resistant, the glyphosate resistant weeds, and that's why we could not control it. But on the right side, when we used glyphosate as a burn down application, and since we were having a celery rye and hairy vetch, so this is a combination of now your herbicide plus your cover crop, and that provided a very good control. If you compare both of these plots, the right side provided you near about 80-85% of the control. Yeah, see, even without looking at this number, just rated this plot just in front of me. So yeah, it's the same kind of percentage, 88 to 97% reduction in horseweed density at burn down. Then another example, 76% seed mortality in 10 months. So this is again highlighting the emergence depth, like we talk about, that it will not emerge greater than 0.2 inches or greater depth. So if you are using any tillage practices, then you can easily reduce the seedling seed viability of that horseweed. This is an example for Palmer Amaranth. When we talk about the moldboard, since we talk about the horseweed, now this is for the Palmer Amaranth. So this is no-till field. So less than, I don't know what's written here. Seed survival when buried. Okay. So this is like, for example, if you have buried the Palmer Amaranth seed to 1 to 4 inches depth for continuously for 3 years. So, that you can do with the moldboard plow. Now the Palmer Amaranth actually can lose 90% of the viability within 3 years. So moldboard plow would be an effective strategy actually for the Palmer Amaranth, because if you are using moldboard plow for every 3 or 4 years, then you can reduce your Palmer infestation by 90%. If you are having a new no-till in your field, I think no-till can also reduce the Palmer infestation in the coming years, because whatever there on the soil surface would germinate in the initial years, and then would particularly reduce the infestation in the later of the coming years. But again, still you had to rely on the germination of or emergence of that Palmer Amaranth in the initial year. What if there is a dormancy in those seeds? Then you never know, and that germination or emergence would not be uniform. So moldboard plow would be actually it would be a very effective strategy here, because whether the seed is dormant or non-dormant, still it would lose viability if you would bury it for 3 to or more than 3 years. So life cycle is normally summer annual for this. Yeah, we are talking about the common ragweed here. So the flowering again in August, seed production is quite high. Seed longevity is 2 to 3 years, and seed emergence step 1 to 1.5 inches. So now here it is increasing actually. So it can emerge from 1.5 inches step. So it is not just like horseweed. So we have to bury it a little deeper if we try to use tillage operations for controlling the common ragweed. Response to tillage improves germination if you are using tillage, and especially if you are using tillage again and again, because it has a longevity of 3 or more years. So you can bring it back again to the soil surface and it would emerge again. Crop rotation, it can avoid peak germination periods and planting date delay, and managing those timings. Cover crops, good when heavy ground cover early in the spring. So that's important if we are maintaining good cover crops for suppressing those weeds. Here, there's one more important thing: movement with the equipment. Seed shatter from plants quickly, not as likely. So since the seeds would shatter very quickly from the plant, so it will not move with your equipment because you were not having enough seeds for your equipments to carry it to the neighboring fields, because most of that seed would actually increase the soil seed bank of the same field where it shatters. Palmer amaranth, I think we already discussed about it. I would save some time over here and would highlight few important slides. So this is just an overall idea about integrated weed management. Start clean. So that's important to eliminate all weeds prior to planting. Use right herbicide, effective site of action, use right rate, use full label rates, apply at the right timing. Basically, like for example, Palmer amaranth and majority of the weeds, we actually target 3 inches or less, so as to control it. If you are passing this stage, Palmer amaranth can grow at a very high speed. If you suppose today you need to apply, and this is a 3-inch long seedling, next day, or if you are delaying the spray application but 2 days or 3 days, it would already pass that stage and you may not be able to control it further. So this is one of the example now to summarize some of the important highlights about these weeds and how you can control it. The horseweed. So this is the emergence timing of this horseweed. So it's like start from February and goes up to May. Its peak time of emergence is like mid March or April. Now, again, it emerges in fall and the peak time is in August and September. And this is actually the planting timings. So it indicates that this is the time when you plant actually. And the Palmer amaranth, actually the peak emergence period in June, July. For the common ragweed, the peak emergence in May. Now, what strategies, like suppose we are looking at the planting timings and cover crops, how we can utilize that knowledge to control these weeds. Here, if we are using a horseweed, and suppose if we are using a cover crops, so cover crop actually would take care of this horseweed during the winters and would suppress it. And here is the time when we would plant our crop. If we are using some of the high biomass cover crop, which we can retain in the field, still it would keep on suppressing the horseweed emergence. So that means with using cover crops or even delaying our planting date a little bit, we can easily control horseweed. Now, again, for the common ragweed, it's a similar case. If we have a cover crop, this is the window when we can plant. Either we just delay the planting a little bit, or having a higher load of biomass of the cover crop retain on the field, that would help to suppress this common ragweed. However, if we talk about the common ragweed, Palmer amaranth, that may not be helpful because whatever cover crop we have is in this time zone. and then it start emerging, and this major emergence time period is in June, July. So we may not expect actually our cover crop to help during this time. And then it comes um, the other strategies like whether you have rotated your crop or not, and what herbicide program are you using, and especially if the weeds are resistant or not. If those are resistant to glyphosate, then are you rotating it with the Liberty Link varieties? So those are the different strategies which we can look for. But based on this major graph, you can see that um, if I compare all these three, Palmer Amaranth is more tricky just because the timing of its emergence. It's basically during the main season of the crop, whereas the horseweed and common ragweed, if we talk about the integrated weed management, and if we are just not focusing on the herbicides, we have a lot of viable options to control horseweed and ragweed. For the Palmer Amaranth, though, again, if we talk about the integrated weed management, then we can bring the harvest weed seed control or the Redicop we just talk about. So those would be the very effective strategies for controlling Palmer Amaranth over here, if we are not just focusing on herbicides. With all, I would like to thank you all and all the contributors of this presentation. And this is our website, Grow website, where you can see our combined efforts, where we place all the presentations and study material. Please go visit and look for the contents at this Grow website. With that, I would like to thank you all. Thank you very much.
All right, Vijay, we have a couple questions. First, can we give us a better explanation of planting date, as research has shown it to be the most important aspect of a complex rotation plan? Planting crops of diverse planting date is a key to keeping weeds off balance and guessing. Relative to this, can we emphasize that a simple crop rotation plan can in some instance escalate weed problems in a field, especially if it leads to a similar weed management practices?
Well, yeah, so I don't know if this question just came in at the last moment or not, but this slides, which we just talk about, actually it's summarizing that planting times and how that can be helpful in managing these weeds. So the example I just gave about the horseweed, and since we are focusing on the horseweed, and this is one of the major weed we have. So like, for example, the major emergence time period is in early April. But still it can emerge even later, like up to May, right? So if we are delaying our planting time to 1st of May or even a little later, especially for the soybean farmers, this is quite helpful because they can delay planting a little bit. And by that time, actually, horseweed would already pass their emergence time period. So we may not be having horseweed emergence later on once you started clean. Started clean means you can use the stale bed seed technique. Whatever emerged, just use herbicide or the tillage operations. You can easily kill horseweed and then start clean with the planting of your cover crop. Even by if you are planting end of April or first week of May, like especially for the corn plantings, still you may not see much of the horseweed because you have already passed, horseweed has already passed their emergence time period. Again, same thing for the common ragweed and Palmer Amaranth. We may not be able to play that role of planting early or later because our major window is just in between. But yeah, as I indicated, there are some other strategies which we can use here. Even here, if you are a soybean farmers and you can delay a planting a little bit so that your major flush, like you allow your seedlings, Palmer Amaranth, to germinate and then kill it, start clean. At least that would help in taking care of the early stage of your crop, because then it would make your crop more competitive in fighting with these weeds. I hope I answered this question.
Here. We did want to acknowledge support for this project, particularly the Maryland Soybean Board, as well as throughout the Mid-Atlantic, University of Delaware, Virginia Cooperative Extension, University of Maryland,